Hello, in this lecture we will revisit the notion of registration that we already discussed in a previous lecture using class methods. So the idea is to analyze what are the alternatives to class-based method registration and to see if we can design something that is as dynamic but less expensive. So if you remember, before starting, a class is a regular object. We can send messages to classes and each class can answer specifically. We can add new method on classes. For example, if I do object all subclasses, I will get all subclasses of the object class, and I can collect all classes that can answer to the full message. And of course, it means that I need to define the full method on the classes, or it should be inherited to make it work. And if you remember correctly, in a previous lecture, we already spoke about an extensible design by iterating over subclasses. For example, in the pillar parser, we were able to compute dynamically the document classes that represent the nodes of a document. And then to parse a line, we were able to dynamically select the right node that can parse a specific line. So this mechanism is a kind of pre-registration mechanism based on class methods. So it means that each time a new class is loaded in the system, a new subclass of document item, it will be taken into account for free. You have nothing to do as a programmer. But the cons is that each time you need to query the system. You need to query the system to get all nodes that can parse a line, all document item subclasses. And this is really costly. You need to do it all the time for nothing. And this is an expensive mechanism. So what we can do to improve this situation? Solution one, we could pre-compute the list of classes and write it directly in the code. So here in the code, we replaced the document item all subclasses by a fixed collection of classes, section, list, and paragraph. And then we can sort them by priority. We can even do better. We can directly order the list correctly, and that the priority is directly embedded inside the collection. So now the evaluation of this solution is that we do not have to query the classes all the time. So this is a good point. But the cons is that you have to keep the list up to date. So it means that each time you will load a new class in the system, you need to revisit the list, change the code, recompile the method. So this is an explicit list that is written in the code, and this is not really extensible by design. The next solution is to have an explicit registration mechanism. So it means that now in the pillar parser, we will store in a class variable a dictionary or a collection of classes that can represent an item, a document item. And of course, I need to add a way for classes to register themselves. So I will provide a method, a register class, like that a new class in the system can register itself in the pillar parser, saying, okay, now I can handle those elements in a document. For example, if I have a section class and I load it, when I initialize the class, it will register itself directly in the pillar parser. The same for paragraph. So this new mechanism is really interesting. There is no need to maintain the list of classes manually, so the developer is free to do it. It's not written explicitly in the code. It's completely dynamic. It means each time I will load a new class, the class can itself register itself in the parser. The registration could support priority, and external classes can also register. This is not mandatory that classes that register are part of the same package as the pillar parser. So here we have an example of that. The extra class that could be packaged in another package can register itself in the pillar parser. And the really good point is that the extra class could be packaged in a separate package from the pillar parser, and also the dependency is reversed. It means that there is a dependency between the extra class and the pillar parser, and not between the pillar parser and the extra class. So this is really better from the dependency point of view. But with an explicit registration mechanism, also we need an unregistration mechanism. So it means that now the developers should provide an explicit way for unregistering document item. And for that, the pillar parser will provide a method to unregister a class. And of course, this is the responsibility of each class to unregister itself when it is unloaded, for example. As a conclusion, the pattern using all subclasses is a very nice pattern, but it is costly. So you need to know it. And usually it's much better to use an explicit registration mechanism, but it's not free. It means that you need to implement it, and you need to provide a way to unregister it, to unregister elements, etc. So it means that it's always about trade-off. Can I use the free mechanism, or should I use an explicit one and code it completely?